right, ladies and gentlemen, some of you seem to think I needed a theme song for my videos, and I think we're going to go with that one for the moment. That enough dubstep for you there, Alex? Okay, so what we are talking about to start with is the reactions of acid chlorides to the other derivatives. Remember, one of the rules we had was take a look at that derivative chart we made last time. Look at that derivative chart. And what you'll see from that is you can go from the carboxylic acid to any of the derivatives in one step. You can also go backwards to the acid in one step, and you can go down that chart, but you cannot go back up without first going through the acid itself. All right, so we know how to make the acid chloride. Really fast review. You do it this way. The carboxylic acid reacts with thionyl chloride to give you the acid chloride. So today, what we're going to talk about is the acid chloride going to an acid anhydride, an ester, a carboxylic acid, an amide, and then finally the salt. All right, all of these can be done in one step, and that's what we're going to look at. So to start with, why don't we do this? Acid chloride to the acid anhydride. What we're about to do will lay the foundation for all of the reactions for the acid chlorides and for the acid anhydrides. For esters, from the acids to the esters and amide, you got to invoke some kind of nucleophile pathway in there as well. All right, so here's how this works. To go from the chloride to the anhydride, you use the carboxylate salt. Now, folks, the mechanism for this is like falling off a log easy. The anion on the salt nucleophilically attacks the carbonyl carbon, knocking off the chlorine. And folks, here's your product. In terms of getting this reaction to work, this is really easy. Now, there's a couple things I do need to say here. Part of this mechanism is a bit of a damn dirty lie, because what it would in reality most likely be is this. Because whenever there is a nucleophilic attack on a carbon, what's going to break first? Your sigma or your pi bond? And the answer to that, hopefully you'll know, is a pi bond, which will give us this as an intermediate. And I am totally out of room down here. I apologize. So there's the attachment. Pi bond reforms, knocks off the chlorine. You get to the exact same spot. How picky am I about which one of those two paths you can use? Honestly, I'm fine with either one. Neither one's going to give me too much heartburn. This one is probably more accurate. This one is a lot easier to teach and learn. So it really just depends on what you're looking for. All right, so now that we've made the anhydride, I don't know what got missed there, and I apologize. So hopefully not too much. It just shut off on me again. So here we're talking about making asymmetric acid anhydrides. What you may wonder is why you would want to make asymmetric anhydrides, and the answer to that is, I don't know, reasons. So you mix your acid chloride and your acid salt. So you might be asking yourself, which one of these, there are two paths to make this, so I'm a little thrown by the fact that I had to restart my recording again. Could you do the reaction this way? Use this as your acid chloride and that as your carboxylate ester. Would mixing these two give you the exact same product? Yes, they would. The only reason the red pathway here might be slightly preferred over the white is this is the carbon where all the action is taking place on the acid chloride carbon, and the one from the linear acid is probably less sterically hindered. But either way, both of these would work, and especially great if you use it in paper chemistry, or in this case, electron chemistry. Now, next one, acid chloride to the ester. Well, folks, this is really easy. What you do is you react the acid chloride with the alcohol. Now, you're probably out there asking yourselves, do we need the electrophilic or acid catalyzed pathway here? The answer to that is no, because the chloride is such a good leaving group that you don't have to pull any funny tricks here. I'm going to let you see if you can figure out this mechanism. I'm going to give you a couple minutes to do it, so hit pause and we'll come back when you're done and see if you got it right. Oh, that was quick. You guys are really good. So, here we go. Acid chloride. The alcohol. Nucleophilically attacks that carbon, knocks off the chlorine, giving you this. We're almost home. We got to find a way to lose that proton. Honestly, there's a bunch of ways you can do it. There's a bunch of different ways you can do this. You can either use an acid scavenger, or you can just be really lazy. Say something like minus H plus, and it gives you your ester. All right, amide is the next one on our list. To make an acid chloride into an amide, we react the acid chloride with 2 molecules of whatever your amine is. And your product, your major organic product, would be this. So you might be asking yourself, why 2 amines? Well, here's the reason why. Mechanistically, this is going to look exactly like the last ones did. Pair of electrons on the nitrogen nucleophilically attacks that. All right, there's your intermediate. You got to ask yourself, what's the best base floating around this system to pull that proton off? Well, it's another one of these bases, of these amines. So, that's why we need 2 of them, because one of them will always be consumed in the deprotonation of the amine. Now, you're not limited here with the types of amides that you can make. For instance, you could make this, which is a primary amide, this, which is a secondary amide. And so it all just depends on which structure you want to go for. Here you would use a primary amine, and down here you would use a secondary amine. I'm running out of time, folks. I got one more for you. Hopefully my computer won't glitch on me again. Which it just did. Isn't that fun? Acid chloride to salt. This is easy, ladies and gentlemen. Hydroxide attacks the carbonyl carbon, knocks off the chlorine, gives you this. And there's enough base sitting around this reaction to just snag this proton off. God bless Vespucci land. This is hard. To make the salt. Okay. By the way, in case you are interested, this is also the way you can make the carboxylic acid. All you need to do is react the acid chloride with water. All right, ladies and gentlemen, that's all I got for you right now. Tune in next time when hopefully my technology behaves itself a little bit better. And we can also look at how we make anhydrides beyond just the ones that we did. And we can make anhydrides beyond the ones we just did and see how they react as well. So, for Organic Chemistry 2, I'm Kurt Weigel. And my music isn't playing me off because it's irritating. That's what I get for trying to be clever. Here we go. Man, that was anticlimactic.